In this video, we use the chain rule to find the derivative of some trig functions, which are compositions. So we're going to use the chain rule. So this function number one we see is y equals sine 4x. And what I can do if I desire to do this is I can put parentheses around that 4x so I can really see that this is a composition of functions. It's sine, and inside the sine function is 4x. And then if I want, I can write on the side of the paper y equals sine of u. And I can write u equals 4x. The way the chain rule works is that the derivative of y is equal to the derivative of sine u. Now we have to remember the derivative of sine u is cosine u. So we take the derivative of that outside function, and we get cosine u, and then what we multiply is by the derivative of u. So you multiply by the derivative of the inside function. And as we can see by just looking right here, okay, well, hopefully we understand this, the derivative of u is the derivative of 4x, and the derivative of 4x is 4. Now, when I write prime, I mean, what I mean is the derivative with respect to x. And then over here also, when I have u, what I can do is replace u back by 4x. So some people will do all that, but some people would just sort of look at this and not write this little side work. They look at sort of ignoring what's inside, they just look at sine. What's the derivative of sine? The derivative of sine is cosine. And then copy and paste what's inside right there, the u, we put u back in there. And then we multiply by the derivative of 4x. And we can choose to put the derivative of 4x after, but I'm going to put it before because it sort of looks better in this situation. But you can put it either way. So the derivative of 4x is 4. The side work over here is, sort of confusing, but you can always do that. And we don't want to be overburdened though by introducing a lot of variables and stuff. So in this case, let's go to the next one. In this case, we have y equals 7 tangent u. So this part here is what we call u, and so u is 3x. Okay, so you can do that on the side if you want. All right, so let's go ahead. Let's pick a good color, green. Y prime is what? Well, now first of all, even though some people they look at this and they say, oh, that's a product, but don't use the product rule. It's just a constant. The rule is if there's a constant, we leave the constant alone. Okay, so that constant outside stays alone. But we have to know what the derivative of tangent is, tangent u, this guy. And you ignore what's inside. You just say 7 tangent u. Well, the derivative of tangent u is secant squared u. Sort of the thing that you're supposed to memorize. Okay, and we could write that over here if we want also. The derivative of 7 tan u is 7 secant squared u. But then we multiply by u prime. All right, and we're going to put u back inside. You keep the inside function the same. But what's u prime? Oh, well, that's a question again. Do I want to put u prime there? I sort of don't like doing that. I want to put the u prime over here, maybe a different color. I can either, it's multiplication. I can put it in front or behind. So that's 3. And then the final answer, y prime equals 21. 21 secant squared 3x. Alrighty. So let's just see if we can, without writing all that stuff down, do this problem here. And let's pick a bright color here. It's pink. Y prime equals what? I ignore what's inside. That's u. So do you know the derivative of secant u? That's the question at this point. We're breaking it down just to that question at first. What's the derivative of secant u? It is secant u tangent u. That's what that is. And we need to put u in both places. We keep the inside exactly the same. And then what do we multiply? We multiply by u prime, which is 5. So there's a lot of things going on there. Do you want to do it on the side? Maybe not, but maybe you do. Y equals secant u, and then y prime or dy. Well, let's just write y prime. Y prime is secant u tangent u all times u prime, but u is equal to 5x, so u prime is equal to 5. So I'll put the 5 way in front again. Is everything super easy? No, not really, but if you do it enough, a lot of it's just practice and liking puzzles. Let's keep going on. Now I have some other functions. I went through all 6 trig functions here. Y prime is what? Let's ignore this part, u. What's the derivative of cosine u? Negative sine u. Then what's the derivative of 8x? I think I used the wrong one. I didn't want to do. Okay. What's the derivative of 8x? That's u. We need to multiply by u prime. What's the derivative of 8x? 8. Because I have the parentheses there, it doesn't. Okay, look, we never multiply this 8 times the 8x. Don't do that, because that's 8x is sort of locked inside there. So y prime is equal to negative 2 times 8 is negative 16 sine 8x. By the way, remember that all the functions that have a co when you take the derivative give a negative. All the ones without a co don't give a negative. Okay, are we moving along sufficiently here? Having a good time here? All right, don't stop me now. Let's go. Y prime equals what? 7, I just leave alone. Let's check out the derivative of cotangent. The derivative of cotangent is similar to the derivative of tangent, but we co everything. So derivative of cotangent is cosecant squared. See, the derivative of tangent u is secant squared u. The derivative of cotangent u is cosecant squared with a negative. Where can I put the negative? Why don't I put the negative way out here? Like, let's put this, there's the negative. Negative cosine u. U, again, is 3x. Multiply by the derivative of u, which is 3. So, actually all along, this may be too light, right? So, put a dark color there. Okay, so then, let's go and write that y prime is equal to negative 21 cosecant squared 3x. And there we go. I forgot to highlight my answers. So maybe I should be backing up a little like that. Almost done. One more. Oh my goodness. It's definitely got to work at this. All right. Y prime is what? It's equal to the derivative of, okay, just ignore what's inside. The derivative of cosecant u. What's the derivative of cosecant u? What's the derivative of cosecant u? It's like the derivative of secant u. It's cosecant u cotangent u, but with a negative also, because it's a co-function. So what do I mean it's like the derivative of secant u? Because the derivative of secant u is secant u tangent u. But this is cosecant, so I write cosecant u cotangent u. So secant u is the derivative of secant u tangent u. Oh, I have it up here. Derivative of secant u is secant u tangent u. But now I co everything. Derivative of cosecant u is cosecant u cotangent u. And with a negative, the inside stays exactly the same. Those are both u. And now what's this that I multiply? U prime, which is 4. It would look better if the 4 is all the way in the front, so we don't think that somehow I need to, that I'm, anyway, we don't want to mix up this 4 with what's inside. They don't mix. So it'd be, but let's just make it look better by writing y prime equals negative 4 cosecant 4x. It's looking good, except I don't have necessarily maybe enough space. Okay, let's move that over. Then cotangent 4x. That's our answer. Make sure the negative's clear. Okay, that was a lot of stuff, and but they're all similar. So the thing is, what is required on this? First of all, we have to understand the chain rule. And for these problems, I mean, I'm making a lot out of it, but look, they're basically the derivative of sine, but since it's 4x, I multiply the derivative of 4x and multiply by 4. Here I have derivative of tangent 3x, so I take the derivative of tangent secant squared x, multiply by 3. Derivative secant u or secant 5x multiplied by 5, because the derivative of 5x is 5. So I think I'm sort of not really expressed that. All we're doing is we take the derivative of cosine and multiply by 8. The derivative of cotangent multiplied by 3, because the derivative of 8x is 8, the derivative of 3x is 3. Or here, this derivative of cosecant 4x, well, we take the derivative of cosecant u multiply by 4. Okay, but we also have to remember the derivative of cosecant, or cosine, or sorry, sine, tangent, secant, cosine, cotangent, cosecant. We have to know those derivatives for this to work, for us to get this. But I think I've written down way more. Many people, when they get rolling on this, just go directly to the answer. I'm writing a bunch of stuff down, but you just go directly to this. This one, you should put y prime also. Okay, so see how it goes. Thanks.